Welcome back, mathematicians. In this video, we are going to solve more trigonometric equations. This time, the equations will be quadratic in form. So we are being asked to solve this equation where theta is greater than or equal to 0 but less than 2 pi. We have 3 times cosine squared theta is equal to sine squared theta. Our first goal here is to get this equation only in terms of cosines or sines, but not both. To do this, we're going to use the Pythagorean identity sine squared theta plus cosine squared theta is equal to 1. Now, it technically doesn't matter which one you replace. You can replace cosine squared theta if you'd like to, or sine squared theta using this identity. I'm going to go ahead and choose to replace sine squared theta. To do this, I'm going to solve this Pythagorean identity for sine squared theta, which means sine squared theta is equal to 1 minus cosine squared theta. So I'm going to replace sine squared theta with 1 minus cosine squared theta. This gives me an equation of 3 times cosine squared theta is equal to 1 minus cosine squared theta. Now what I have is like terms on both sides of the equal sign. So what I'm going to do is move them over to the same side. I'm going to do this by adding cosine squared theta to both sides. This gives me a new version of the equation of 4 times cosine squared theta is equal to 1. I'm now going to isolate cosine of theta by dividing by 4 first. And so I get cosine squared theta is equal to 1/4. Now, to help illustrate the next step, it's important to note that cosine squared theta is really equal to cosine of theta quantity squared. We don't write it like that, but that's what it's equal to. So what I'm going to do to both sides is take the square root. What I get on the left side is cosine of theta, because the square root undoes the squared. What I got on the right is the square root of 1/4, which is 1/2, but anytime I take the square root of both sides of an equation, I should include the plus or minus. So now I'm looking for angles when evaluated for cosine that equal the ratio of positive 1/2 or negative 1/2. So in your unit circle, you're going to look for the x-coordinates that are either positive 1/2 or negative 1/2. You'll really be looking in all 4 quadrants. So I'll stick with quadrant number 1. If you wanted to draw yourself a quick picture, quadrant number 1 would look like this, where your adjacent side is positive 1, your hypotenuse is 2, and your opposite side is square root of 3. So this is one of the solutions for angle theta. So in quadrant number 1, theta is equal to pi over 3. But because cosine has a positive ratio also in quadrant number 4 and a negative ratio in quadrants 2 and 3, we have an angle defined in each quadrant. So quadrant number 2 would give us a solution of 2 pi over 3, which, by the way, still has a reference angle of pi over 3. Quadrant number 3, would have a solution of 4 pi over 3, which again has a reference angle of pi over 3. And then finally, quadrant number 4 would have a solution of 5 pi over 3, which again has a reference angle of pi over 3. So those are your 4 solutions to this equation. In this equation, we're solving for angles theta that are greater than or equal to 0 but less than 2 pi. Our equation is 4 times the expression 1 plus sine of angle theta is equal to cosine squared theta. Like with the last problem, we need to convert or replace cosine squared theta with 1 minus sine squared theta, so we have an equation that's only in terms of sines and no cosines. So what we have is 4 times the expression 1 plus sine of angle theta is equal to 1 minus sine squared theta. Now what we're going to do is simplify the left side by applying the distributive property. That means we get 4 plus 4 times sine of angle theta is equal to 1 minus sine squared theta. Now this is an equation in quadratic form, and we're going to use our strategies for solving quadratic equations, which means we need to get one side equal to 0. To do this, I'm going to go ahead and subtract 1 to both sides and add sine squared theta to both sides. Now I choose to move the right side over to the left because I really prefer that sine squared theta to be positive, but really you could go the opposite direction if you'd like to. So now I have sine squared theta plus 4 times sine of theta plus 3 is equal to 0. This is my trigonometric equation that's in quadratic form, and you can see that it looks like ax squared plus bx plus c is equal to 0. Now, if one of the strategies I can apply is by factoring this equation and then solving using my strategies for a quadratic equation, or I can apply the quadratic formula. Either one works. If you like to factor, but you look at this and are intimidated by factoring when it's in terms of sine, what you can do is let u equal sine of angle theta, and then you replace sine of angle theta with the variable u. So what you get is u squared plus 4u plus 3 is equal to 0. And for some, this might just be easier for you to factor. The factors of u squared plus 4u plus 3 are u plus 3 and u plus 1. Now what we do is apply the zero product property to get u is equal to -3 and -1. Now we're going to go ahead and back substitute sine of angle theta for u. So what we get is sine of angle theta is equal to -3, or sine of angle theta is equal to -1. Let's start by solving the first equation, which is sine of angle theta is equal to -3. Well, this can't happen. Sine of angle theta will never be -3. The output for sine of an angle is always greater than or equal to -1 or less than +1. So as a result, this does not give us a solution to the equation, to the original equation. We move on to the next equation, which is sine of angle theta is equal to -1. And we're going to go to our unit circle to solve this. So I'm going to draw my unit circle, and what I'm looking for, and pretend that unit circle is centered on the origin, and it looks much nicer than it does, but what we're looking for is where is the terminal side that intersects the unit circle and has a y coordinate of -1. And what we see is that will occur at this point right here, which has an ordered pair of 0, -1, which means it has a y coordinate of -1. So what angle represents the negative y-axis? That would be 3 pi over 2. So as a result, theta in this case is equal to 3 pi over 2, and that is our only solution to the original equation. All right, guys, good luck.